Let's move to the next question. Question number 31. The equation of a circle with origin as a center and passing through the vertices of an equilateral triangle whose median is of length 3a is, first option, x square plus y square equal to 9a square. Second option, x square plus y square is equal to 16a square. Third option, x square plus y square equal to 4a square. Fourth option, x square plus y square is equal to a square. We are given that the circle has the center as origin and it is passing through the vertices of an equilateral triangle. So we have an equilateral triangle inscribed in the circle. Now clearly the circumcenter will be the centroid as well. The circumcenter of this triangle ABC, which is an equilateral triangle, will be the centroid of this equilateral triangle. Circumcenter, centroid, in center, everything will be same for an equilateral triangle. So we have here, but now this median is divided by the centroid, which is also the circumcenter. G is the notation for centroid and S is the notation for circumcenter. We know that in a triangle the median is divided by the centroid in the ratio 2:1. So he says that this length is of this entire AD, length of AD is given to be 3a, which means that AG has to be, AG is to GD is 2:1. Therefore, AG will be equal to 2a. AG will be equal to 2a. Now AG is 2a, but what is AG? Can I say that AG is nothing but the radius of the circumscribing circle? So what is that? So we can say that we are also given that this is origin. So what will be the equation of the circle? X minus 0 whole square plus y minus 0 whole square equals to 2a whole square. 2a being the radius. This will be the radius of the circle. So center is origin and the radius we found it to be 2a. It came from here. For an equilateral triangle, centroid and circumcenter are one and the same. So from circumcenter to any vertex, the distance is the radius. I found the distance AG. How did we find that? AG is to GD is equal to 2:1. Centroid divides the any median in the ratio 2:1. So we use that. Since this entire length was 3a, so that had to be divided in the ratio of 2:1. So this will be 2a and this will be a. So we have AG, which is nothing but the circumradius, to be equal to 2a. So x square plus y square is equal to 2a the whole square. So the answer is, the option, right option is option x square plus y square is equal to 4a square, and the right option is option 3 is the right answer. Let's move on to the next question. Question number 32. If the two circles x minus 1 whole square plus y minus 3 whole square equal to r square and x square plus y square minus 8x plus 2y plus 8 equal to 0 intersect in two distinct points, then first option, r lies between 2 to 8. Second option, r is less than 2. Third option, r is equal to 2. Fourth option, r is greater than 2. Now let's first understand one thing here. When are two circles intersecting in two distinct points? For the two circles to be intersecting in two distinct points, what is the necessary and sufficiency condition? Let us think that the radius of this, the center of this circle is C1 and C2 here. Radius of this circle is R1 and the radius of this circle is R2. What should happen? The distance between the centers must be greater than the difference of the radii. For this to happen, that is, if the two circles are to be intersecting in two distinct points, the criterion is, the necessary and sufficiency condition is, the distance between the centers must be greater than the difference of the radii and also less than sum of the radii. So we'll use these two we'll use this criterion here. What are we given here? We are given that the center of the first circle is 1, 3. And what is the radius R1 for that? Radius is R. We are given that it's R. And the center of the second circle in the given problem is 4, -1. And the radius is R2, we'll write R2, that is 4 square plus -1 square minus 8 under root. What does it make it? 16 plus 1, 17, 17 minus 8, 9 under root, that makes it 3. So R2 is 3. Now what is the center C1 we wrote? We have obtained 1, 3. What is the center C2? 4, -1. Now what is the distance between the two centers? Let's find out the distance. C1, C2 is equal to 4 minus 1 the whole square, distance formula. Okay, minus 1 minus 3 the whole square under root. That is the distance. That makes it 4 square and plus 3 square. That's 25. Under root of that 5. So 5 is this. Instead of C1, C2 we have 5. And what do we know here? Modulus of R1 minus R2, that is modulus of R minus 3 should be less than 5. And that 5 in fact should also be less than sum of the radii, that is R plus 3. Okay. Therefore, clearly our R should satisfy both these inequalities. Now clearly from here R plus 3 is greater than 5. That means from here this part implies, this inequality implies R must be greater than 2. So this R must be greater than 2. So in fact now that rules out the options 2 and 3. So R has to be greater than 2, but then is it going to be less than 8 or not? That we shall see from, we also have to look at this part. Modulus of R minus 3 less than 5. So what is it you can say from here? R minus 3 should lie between minus 5 and 5. Okay, so R minus 3 lies between minus 5 and 5. Therefore, R should lie between minus 5 plus 3, that is minus 2 and 8. But we said R has to be greater than 2. So if it is greater than 2, obviously it will be greater than minus 2. So this will anyway go holding good. So R should be therefore greater than 2 and less than 8. R should lie here. So the range for R, so that these two circles will be intersecting, is 2 to 8. So R value should lie between 2 to 8. Therefore the right option is, option 1 is the right answer. Option 1 is the right answer. Let's move on to the next question. Question number 33. The lines 2x minus 3y equal to 5 and 3x minus 4y equal to 7 are diameters of a circle having area 154 square units. Then the equation of the circle is, first option, x square plus y square plus 2x minus 2y equal to 62. Second option, x square plus y square plus 2x minus 2y equal to 47. X square plus y square minus 2x plus 2y equal to 47. X square plus y square minus 2x plus 2y is equal to 62. Now we are given two diameters, 2x minus 3y equal to 5 and 3x minus 4y equal to 7. So we are given two diameters of a circle. So diameters are definitely lines passing through the center. So when you solve these two diameters, what do we get? We get the center of the circle. So 2x minus 3y equals to 5, and let us say this diameter is 3x minus 4y equals to 7. So when we solve these two equations, what do we get? We get the center, because they both pass through the center. So the center is what? So let's solve it. Okay, 2x minus 3y equal to 5, minus 5 equal to 0, and 3x minus 4y. So let's multiply this with 3. So that makes it, okay, let's multiply this equation with 3 and this with next equation with 2, minus 7 equal to 0. And subtract one from the other so that x gets eliminated. So what do we have this equation to be? This is 6x minus 9y minus 15 equal to 0. The second equation is, when we multiply the second equation with 2, we get 6x minus 8y minus 14 is equal to 0. So subtracting one from the other, we get minus 9 plus 8, that makes it minus y, minus 15 plus 14, that makes it minus 1 is equal to 0. So that gives us y equals to minus 1. So y is equal to minus 1. If y is minus 1, 2 into, now let's move to 2x minus 3y is equal to 5, we know. 2 into x minus 3 into minus 1 is equal to 5. So that makes it 2x is equal to 5 minus 3, that is 2. X has to be 1. So x is 1 and y is minus 1. Clearly, let's verify whether it satisfies it. Yes, it does satisfy. 1 comma minus 1 is the center. Therefore, now once I know the center, what else we require to find out the equation of the circle? We need the radius. So what is the radius? He has given that area of the circle is 154 square units. What is area? Pi r square is equal to 154. What is pi approximately? We know for all practical purposes it is 22 by 7 into r square is equal to 154. So we have here, now this will make it 7 times 22 is 154. R square is equal to 7 square, 7 into 7 there. So r has to be 7. So radius is 7 and center is 1 comma minus 1. So that allows us to write the equation of the circle as x minus 1 whole square. Therefore, circle equation, let me write it here, x minus 1 whole square plus y plus 1 the whole square is equal to 7 square. And on simplification, it's clear that we get x square plus y square minus 2x plus 2y and 1 plus 1, 2 minus 48, or let's transpose that to that side. So we get 47 there. So clearly the right option is answer 3. Answer 3 is the right option. Let's move to the next question. If a circle passes through the point A comma B and cuts the circle x square plus y square equal to 4 orthogonally, then the locus of its center is, first option, 2ax plus 2by plus a square plus b square plus 4 equal to 0. Second option, 2ax plus 2by minus of a square plus b square plus 4 equal to 0. Third option, 2ax minus 2by plus a square plus b square plus 4 equals to 0. And the fourth option, 2ax minus 2by minus a square plus b square plus 4 equals to 0. Let us first understand what does it mean to say that the two circles cut each other orthogonally. What do you mean by angle between two curves or two circles in particular? That is, it is the angle made at the point of intersection by the tangents. Now, if the two circles are intersecting orthogonally, that means the angle between the tangents must be equal to 90. Then this tangent, which is the tangent to the second circle, will actually become the radial line because it is perpendicular to this line, which is the tangent to the first circle, will become the radial line for the first circle. So this will become R1, radius of the first circle. What about this? I am joining the center and radius. Center and this point of contact, point of intersection there. What about here? We have C2. Let us say the radius of this is 2, R2. Now when the two circles are intersecting orthogonally, what should happen? The distance between this will form a right angle triangle. Means that we'll have C1, C2, if you call it as D, the distance between C1 and C2, let's denote it by D, then we'll have D squared to be equal to Pythagoras theorem, R1 square plus R2 square. So D square will have to be equal to R1 square plus R2 square. So this is the condition for orthogonality. Condition for orthogonality. For orthogonality. Condition for orthogonality. of the two circles. Okay. Now he says if a circle is passing through the point A comma B and cuts the circle, so let us say that circle which is passing through A, there's a circle, this circle is passing through A comma B, and it is cutting the circle with the center as some origin, C2 is origin, let's say, and C1, I want the locus of center of this circle which is cutting this circle orthogonally. So let us take this center to be some alpha comma beta. So alpha comma beta is the is a point on the locus. Okay. So what do you know from here? R1 square plus R2 square has to be equal to, what is R2? D square. What is R2 here? 2. But what is R1? Alpha comma beta is the center of the first circle. Therefore, alpha minus A the whole square plus beta minus B the whole square will be equal to R1 square. So R1 square is nothing but alpha minus A the whole square plus beta minus B the whole square. What is R1 square is equal to? R1 square should be equal to D square minus R2 square. R1 square plus R2 square. What is R2 square we have? 4. So R1 square, what is D for us? D means the distance between the centers here. What are the centers? We have assumed one of the circles, that is variable circle, to have the center is alpha comma beta, and the fixed circle with which it is intersecting is with the center origin here. So that therefore D square is equal to the distance between C1 and C2 square. So alpha square plus beta square, that is D square. So now let's equate this. D square is equal to R1 square plus R2 square. So let's come here. What is R1 square? So alpha minus A the whole square, that is alpha square plus beta square minus 2A alpha minus 2B beta plus A square plus B square plus 4. This is okay. This is R1 square plus R2 square. That should be equal to D square. What is D square? Alpha square plus beta square. Alpha square cancels and beta square cancels. What do you have here? 2A alpha. Okay, we have here 2A alpha plus 2B beta is equal to or minus of A square plus B square plus 4. A square plus B square plus 4 is equal to 0. I am taking a minus common here. But then we wanted the locus of alpha comma beta, so we replace alpha comma beta by the general coordinates there. Therefore, the locus of alpha comma beta is 2ax plus 2by minus a square plus b square plus 4 is equal to 0. So this is the required locus, and that is appearing in the option 2. Option 2 is the right option there. So the point that we have to bear in mind here is that the condition for the two circles to be cutting each other orthogonally is square of the distance between the centers must be equal to sum of the squares of the radii. So that's what we had used. We are interested in the locus of a circle which is cutting this fixed circle orthogonally. So let us locus of center of that circle which is cutting it. So let us take the center of the circle as alpha comma beta. We wanted the locus of alpha comma beta. So we have actually framed an equation alpha and beta. So answer option 2. Option 2 there. Let's move to the next question. Question number 35. A variable circle passes through a fixed point A with the coordinates p comma q and touches the x-axis. The locus of other end of the diameter through A is, first option, x minus p whole square is equal to 4qy. Second option, x minus q whole square is equal to 4py. Third option, y minus p whole square is equal to 4qx. And fourth option is y minus q whole square is equal to 4px. There is a variable circle which is always passing through a fixed point. So there is a circle which is always passing through a fixed point P comma Q. We can have infinitely many such circles. Now, the other end of the diameter, we wanted the locus of this. Let us take this other end of the diameter as some alpha comma beta. Now, how is this circle? He says this circle is always touching the x-axis. Okay. So now, can we write the equation of this circle using this other end? We know, when you know two diametrically opposite points in a circle, what's the equation of the circle? If x1 comma y1, and x2 comma y2 are endpoints of a diameter, of a circle, equation is given by x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. This we know. So this is the formula we will be using here. Okay, so let us think that this is x1 y1 and this is x2 y2 here. So what will be the equation of this circle? X minus alpha into x minus p plus y minus beta into y minus q equal to 0. Okay. Now for this circle to be touching the x-axis, what is the criterion here? Can we say that the y coordinate of this center will have to be the radius? Y coordinate, modulus of the y coordinate of the center has to be the radius. Okay, here clearly what's the modulus of the y? What is the center here? Alpha plus p by 2 comma beta plus q by 2. Now beta plus q by 2 is the modulus of beta plus q by 2 must be equal to, I'll say, the radius. What's the radius? Half of the diameter. Can we say that? Or we can say that's equal to half of the diameter. That is alpha half of, what's the diameter? Alpha minus p the whole square plus beta minus q the whole square. That is the diameter under root. Under root of that is the diameter. Modulus of beta plus q by 2 will be the, because it is touching the x-axis, this will be the radius. And the radius is equal to half the diameter. What is the diameter? Alpha minus p whole square plus beta minus q whole square under root will be the diameter. So diameter of this. Now what we can do is, we'll square both sides. What do we get? Beta plus q whole square by 4 is equal to alpha minus p whole square, and in fact actually this 2 can be cancelled first and we'll just square both sides here. Beta plus q whole square is equal to alpha minus p whole square plus beta minus q the whole square. So from here clearly alpha minus p whole square is equal to beta plus q whole square minus beta minus q whole square. Now that is clearly in the form of, this has to be in the form of 4 beta q. This is in the form of 4 beta q, and that is alpha minus p the whole square. You wanted the locus of alpha comma beta. So what shall we do? We shall replace this alpha comma beta by the general coordinates x comma y. Therefore the locus of alpha comma beta is x minus p the whole square, that is I replaced alpha by x and y beta by y. So alpha minus x minus p the whole square should be equal to y, beta has to be replaced by y, so y 4yq there. So x minus p whole square is equal to 4yq, and that is appearing in the option 1. So option 1 is the right option. That's the right option. Actually, we could have done this in another way. That is, we wrote the equation of the circle. For this circle to be touching the x-axis, what is the criterion? Another way we can look at it. So let me illustrate to you the other second method. Method 2. X square plus y square plus 2gx plus 2fy plus c equal to 0. If this is the circle equation, the x-intercept made by this circle, with that is a circle, suppose it's cutting the x-axis in 2 points, A and B. This length AB is given by 2 root of g square minus c. 2 root g square minus c. Now what will be the criterion for that circle to be touching this x-axis? If this is x-axis, so A and B should be coinciding. In other words, this intercept has to become 0. That is, this circle, the circle touches x-axis if and only if g square is equal to c. That is half, what is g? Half the coefficient of x. So we could have picked up the coefficient of x. What is the coefficient of x here? P plus alpha. Half the coefficient of x means p plus alpha by 2. Okay, square of that must be equated to c. What is c here? The constant term, alpha p plus beta q, whatever will be the constant term. So when you do that also, you will get the same equation that we have got in the previous method. In the previous method, what did we do? We just used the fact that, when it is touching the x-axis, the y coordinate of the center has to be, modulus of the y coordinate of the center has to be equated to the radius. But what is the radius? Half the diameter. We use that fact there. Now we can even do it in an alternative manner, that is method 2. This is criterion for condition for the circle to be touching the x-axis, that is g square equal to c. Let's move to the next question, question number 36. If the lines 2x plus 3y plus 1 equal to 0 and 3x minus y minus 4 equal to 0 lie along the diameters of the circle, this of circumference 10 pi, then the equation of the circle is. Again, it's similar to the question that we have done. So what is it? We are given two diameters, 2x plus 3y plus 1 equal to 0. Where do they intersect? They intersect on at the circle. So 3x minus y minus 4 equal to 0. So solving these two, we'll get the center. And what else is required to write the equation of the circle? We require some way to find out the radius. Circumference is given to be 10 pi. What is circumference? 2 pi r. So radius will be 5 units there. 2 pi r is given to be 10 pi clearly. So r has to be 5. So radius has been found to be 5 units. Now what else you require now? We just need to find out the center. So how will you find out the center? What we'll do is we'll multiply the second equation with 3 and add up. So 1 and 2, second equation. First equation plus 3 times the second equation. Let's do that. So what do we get? 2x plus 3y plus 1, and we have, when you multiply the second equation with 3, 9x minus 3y minus 12 is equal to 0. With adding the two equations, we get 11x, this cancels, and 1 minus 12 minus 11 is equal to 0. So x is equal to 1 there. X is 1. When x is 1, what is the value of y? Your y is equal to 3x minus 4. Y is equal to 3x minus 4. So that is 3 into 1 minus 4, that makes it minus 1. So y is minus 1. So clearly the center is 1 comma minus 1. X is 1 and y is minus 1. and the radius is 5 units. That we have already found. Therefore, the equation of the circle, I can now write it as x minus 1 whole square. This is the circle equation. X minus 1 whole square plus y plus 1 whole square is equal to 5 square, that is 25. So that makes it, when I open it up, what do we have? X square plus y square minus 2x plus 2y, 1 plus 1, 2, 2 minus 25 minus 23 is equal to 0. That's clearly appearing in the option, first option, very first option, and therefore answer is 1. Answer is the first option, option 1. So let's move to the next question, question number 37. The intercept of the line y equal to x by the circle x square plus y square minus 2x equal to 0 is AB. Equation of the circle on AB as a diameter is, first option, x square plus y square minus x minus y equal to 0. Second option, x square plus y square minus x plus y equal to 0. Third option, x square plus y square plus x plus y equals to 0. Fourth option, x square plus y square plus x minus y equals to 0. There is a circle x square plus y square minus 2x equal to 0. It's clearly passing through origin, and center is, you can say 1 comma 0 is the center. All right. Now there's a line y equal to x which is cutting it in 2 points A and B. One of the points is clearly the origin. Y equal to x passes through origin, and the circle is also clearly passing through origin. Origin is, when you substitute origin, it satisfies the equation. So one of the points of intersection is origin. Anyway, let's solve it with y equal to x. So when you solve with y equal to x, substituting here, you get 2x square minus 2x is equal to 0. I'm putting y equal to x here. So what do you get? X, 2x into x minus 1 is 0. Forget this 2, x is 0 or x is equal to 1. When x is 0, you get the point 0 comma 0, because this line is y equal to x. So y coordinate should coincide with x coordinate. What about b? X equal to 1 will give me the point b, 1 comma 1. So 1 comma 1. Now what do we have to find out? We have to take AB as a diameter of a circle and find the equation of that circle. Right? We have to find out the equation of this, a circle passing through this A and B, and which will contain AB as a diameter. Right? So the given circle M is actually not the circle. So we have to find the circle. How do we find out? We know 2 ends of a diameter. When x1, y1 and x2, y2 are end points of a diameter, what is the equation of the circle? X minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. So AB as diameter, circle with AB as diameter is x into x minus 0 into x minus 1 plus y minus 0 into y minus 1 equal to 0. So what is that? Clearly x square plus y square minus x minus y is equal to 0. That's the equation. So clearly that is appearing in the option 1 is right option. Option 1 is the right option. Okay, let's move to the next question, question number 38. If the circles x square plus y square plus 2ax plus 2cy plus a equals to 0 and x square plus y square minus 3x plus dy minus 1 equal to 0 intersect in 2 distinct points P and Q, then the line 5x plus by minus a equal to 0 passes through P and Q for, first option, exactly one value of a, second option, no value of a, third option, infinitely many values of a, fourth option, exactly 2 values of a. So let's have a look at this question. Here we have a circle, another circle here. Let's say we have another circle. S1 equal to 0 is S for second degree equation. So S1 equal to 0 is one equation, one circle equation. S2 equal to 0 is the other circle equation. if they are intersecting in two distinct points, this common chord AB, this common chord, it's called the common chord. This common chord is given by S1 minus S2 equal to 0, provided we make both the equations into standard form. What do you mean by standard form? That is, the coefficient of x square and coefficient of y square have to be made 1 in both the equations. So that what happens is this S1 minus S2 will become a linear expression. So S1 minus S2 will not have the second degree terms, x square and y square terms should get cancelled. So in order to make that, we should bring both S1 equal to 0, that is the first circle equation, and second circle equation in the standard forms, and subtract one from the other. That gives us the common chord. So in our context, what is S1? In the given problem, S1 is x square plus y square plus 2ax plus cy plus a. This is S1. S1 equal to 0 is the first circle, let us say. Second circle is x square plus y square minus 3x plus dy minus 1 equals to 0. Now, what is the common chord for this? What's the common chord? S1 minus S2 is the common chord. Subtracting, we have, see, when we are doing that, we have to first check whether they are in the standard form or not. Clearly, the equations are given in the standard form. See, in the sense that the coefficient of x square and y square are given to be 1s there. So subtract one from the other. What do we have? 5ax and plus c minus d into y plus a plus 1. That is S1 minus S2. That equated to 0 is the common chord. But he says they are intersecting in points P and Q. These points he has given were P and Q. So there is a line passing through P and Q, and that line, he says, is given by 5x plus by minus a equal to 0. So that now this is PQ, but PQ is also given by another equation, 5x plus by minus a equal to 0. Okay. Now, if two equations are representing the same line, what should happen? The coefficients of the like terms must be proportional. So what should have happened here? 5a by 5, that's the coefficient of x, should be same as c minus d by b, and that should be same as a plus 1 by minus a. Okay. So that makes it, what does it make it here? Now we have here a here. A therefore should be equal to, now we are interested in for what values of a this can happen. So what we do is, let's equate the first expression and the last expression. A should be equal to a plus 1 by minus a. So we will carry that a squared should be equal to minus of a plus 1. In other words, a squared plus a plus 1 should be 0. Now this is a quadratic equation in A. What is A? A has to be a real number. Can any real number be satisfying this equation a square plus a plus 1 equal to 0? What is the discriminant of this? This discriminant of this quadratic expression is negative. Clearly, b square minus 4ac, 1 square minus 4 into 1 into 1. That's negative. So the discriminant is negative. Hence, no real value of a will exist. So what is the right option? No value of a. No value of a. Option 2 is the right answer. A circle touches the x-axis and also touches the circle with center 0, 3 and radius 2. Then the locus of the center of the circle is an ellipse, a circle, a hyperbola, a parabola. Now there is a circle of fixed circle whose center is 0, 3. That is, center is lying along the y-axis. 0, 3 is the center, and the radius is 2 units. radius is 2 units. Now there is a variable circle. There is a circle touching the x-axis and also this circle. We have a circle like this, touching the x-axis and this circle. Okay. When two circles are touching externally, so this can happen only when the circles are touching externally. So this situation can happen that way. When the two circles are touching externally, what is the criterion? Distance between the centers must be equal to sum of the radii. Okay. We are interested in the locus of the center of the circle. Let's take the center of the circle to be alpha comma beta. Okay. Now alpha, what is this length going to be? Beta. Radius will be same as beta here, because I need not have to take mod beta, because anyway beta has to be positive. The circle is above the x-axis, the y coordinate has to be positive there, so I can take beta to be the radius there. So this is also beta then. Okay, so now what is it? One of the circles is having the center is alpha comma beta, the variable circle, and has the radius as beta, and other fixed circle has the radius as 2 and the center is 0 comma 3. Now what is the distance between the centers? Distance between the centers must be equal to the sum of the radii. That is the criterion. So what is that? Alpha minus 0 whole square plus beta minus 3 whole square under root. That's the distance between the two centers, C1, C2, and that must be equated to sum of the radii. What is sum of the radii? Sum of the radii, that is 2 plus beta. 2 plus beta. Okay. Now we'll square both sides now. What do we have? I want to get rid of the square root. Alpha square plus beta minus 3 the whole square is equal to beta plus 2 the whole square. So that makes it alpha square. Okay, alpha square is equal to beta square plus 4 beta plus 4. Let's carry this beta minus 3 the whole square that side. That is minus of beta square minus 6 plus 6 beta plus 9 minus 9. Because plus 9, then I take it the other side, minus 9. I have beta square cancels, and we have here 4 beta plus 6 beta, that is 10 beta minus 5. So I have here alpha squared to be alpha square is equal to 10 beta minus 5. So what's the locus of this? What is the locus of alpha comma beta? It's in the form of x square is equal to 5 into y minus 5, 10 into y minus half. It's clearly a parabola with vertex as 0 comma half. It's a parabola with vertex as 0 comma half. We know that we would have learnt in the parabola chapter, that is x minus h whole square is equal to 4a into y minus k, represents a parabola with vertex as h comma k. With vertex as h comma k, it will be in fact x equal to h will be the axis of symmetry. H comma k will be the vertex. It's a parabola. So is it in that standard form? X square. So instead of h we have 0. So x minus 0 the whole square. Instead of 4a we have 10. Y minus k, what instead of k we have half. So it is a parabola with vertex as 0 comma half, and the axis of symmetry being x equal to h means x equal to 0 here. Right. So the right option is answer 4. Option 4 is the right option. Let's move to the next question, question number 40. Let's see with a circle with center as origin and the radius 3 units. the equation of the locus of midpoints of the chords of the circle C that subtend an angle 2 pi by 3 at its center is, first option x square plus y square equal to 3 by 2, second option x square plus y square equal to 1, third option x square plus y square equal to 27 by 4, fourth option x square plus y square equal to 9 by 4. Now let's have a look at this question here. Center C is a circle with center is origin, and it says, and the radius is 3 units. Radius is 3 units. Now there is a chord which is, you pick up any chord which is subtending subtending an angle 2 pi by 3. So 2 pi by 3 is 120 degrees. Now there can be various such chords which subtend the same angle. You just keep rotating this frame entirely about origin. If you keep rotating, you get this various chords. Let us say AB is the position of one such chord where the angle subtended by it at the center is 2 pi by 3. So when you drop a perpendicular from the center O onto AB, let's say it is meeting at C. Now C will have to be the midpoint of AB. C will have to be the midpoint of AB. And what about this? This triangle and this triangle will be congruent to each other. Clearly this angle will be pi by 3 because this is total is 2 pi by 3. This will act as a bisector OC, perpendicular bisector of AB. It's also angular bisector of angle O because this OAC triangle is congruent to the triangle OCB. Therefore, this angle will be pi by 3. This part is also, this total is 2 pi by 3. So this will also be pi by 3. Now, we are interested in the locus of midpoint of this chord. So let us take that midpoint as some x1 comma y1. So what we want is locus of x1 comma y1. Okay. Now, so we have to frame an equation involving x1 and y1. What's the thing that comes to our mind? Now, can we use the distance formula? OC square is equal to, what is OC square? Or OC is equal to under root over x1 square plus y1 square. That's using the distance formula. Okay. But what is OC? It is 3 cos projection of this OB along this line. So what is that? OC is equal to, but OC is 3 cos pi by 3. That is 3 by 2. So under root over x1 square plus y1 square is equal to 3 by 2. Now we already have an equation satisfied by x1 comma y1. So what do we need to do? What we need to do is, we need to actually frame an equation in x1 and y1 because we wanted the locus. So we'll just square it. What do we have? X square plus y square is equal to 9 by 4. So clearly the right option is answer 4. Option is 4. Okay, let's move to the next question. Question number 41. Consider a family of circles which are passing through the fixed point 1, minus 1, comma 1 and are tangent to the x-axis. That means they must be touching the x-axis. If h comma k are the coordinates of the center of the circles, then the set of values of k is the given interval. First option is k should lie between 0 to half, k greater than or equal to half, and third option is k should lie between minus half to half, and fourth option says k has to be less than or equal to 1 by 2. So let's have a look at this. We have a variable circle but passing through a fixed point minus 1 comma 1, minus 1 comma 1, and also touching the x-axis. Now what is variable in it? Center is a variable thing and also the radius. But all the circles are, however, passing through minus 1 comma 1. Let's say h comma k is the center. That is of course given there. Now what will be the radius given by? Clearly the y coordinate of the center with an absolute value will be the radius. So mod k is the radius. clearly. But then the radius can also be equated this way, the distance from center to any one of the points on the circle. So we will equate like that. So what do we have? H plus 1 the whole square plus k minus 1 whole square is equal to mod k square, that is k square. What did I do? We found the radius in two different ways. That is, we found, since it is touching the x-axis, the y coordinate of the center in the absolute value of the y coordinate of the center has to be equal to the radius, and radius can also be found as the distance from center to any point on the circumference. So what do we have? H square plus 1 plus 2h plus k square minus 2k plus 1 is equal to k square. So clearly this k square and k square we can cancel out. What do we have? H square plus 2h plus 1 is equal to minus 2k. H square plus 2h plus 1 is equal to this minus of 2k minus 1 plus 1, because when I bring it that side, sorry, it's to be 2k minus 1. When I take that minus 2k that side, becomes 2k, and this 1 that we carry will be like this. Clearly this part is a perfect square, that is h plus 1 the whole square. H plus 1 whole square, this is a perfect square, that's non-negative. So 2k minus 1 has to be non-negative. So very clearly from here k has to be greater than or equal to half. So the right option is option 2. Option 2 is the right option. Let's move to the next question, question number 42. If P and Q are points of the intersection of the circles x square plus y square plus 3x plus 7y plus 2p minus 5 equal to 0, and x square plus y square plus 2x plus 2y minus p square equal to 0, then there is a circle passing through capital P, capital Q and 1, 1 for first option all values of P, second option all values of P except one value, third option all except two values of P, and the fourth option is exactly one value of P. Now there's one thing that we should note. Suppose you have two circles intersecting in two distinct points, or maybe touching each other also for that matter. When you have two circles S1 equal to 0 and S2 equal to 0, two circles, any circle passing through the intersection of these two circles, any circle passing through this intersection, we have infinitely many such circles. We can have infinitely many circles passing through this. So all these circles are given by S plus lambda times S1 plus lambda S2 equal to 0, where lambda is any parameter, lambda any real number. That is, if you keep changing the values of lambda, we get different circles passing through the intersection of S1 equal to 0 and S2 equal to 0. Let's just have a look at this. Now let us say A is a point of intersection. Is A going to be satisfied by S1 equal to 0? Yes, A is a point on S1 equal to 0. So when I put A, that makes S1 as 0. Is A a point on S2 equal to 0? Yes. So lambda into S2 at A also will become 0. So what is going to happen? So S1 plus lambda S2 is going to be 0. Whatever may be the value of, that equation will be satisfied by this point A. So will it be satisfied by the point B also. The point B will also satisfy it. So clearly this is a circle which passes through the intersection of the two circles S1 equal to 0 and S2 equal to 0. Now he says the points are P and Q. The points are P and Q. P and Q. And we are interested in finding out whether there is a circle passing through these 2 points P and Q and also passing through a point 1, 1. Okay, so let's see if that's possible. So what is it? We should have x square plus y square. How do you write a general circle passing through P and Q? A circle passing through P and Q. Circle through PQ. P comma Q is given by S1 plus lambda S2 equal to 0. What is S1? X square plus y square plus 3x plus 7y plus 2p minus 5 plus, this is S1 part, lambda times the second equation, x square plus y square plus 2x plus 2y minus p square equal to 0. Okay. Now, this circle has to be passing through 1 comma 1. So, we are interested in such a circle which passes through 1 comma 1. So, is there a possibility of getting a circle passing through P and Q which will be which will also be passing through 1 comma 1. So, let us see if it is possible. So, let us substitute the point 1 comma 1 and see what do we get here. This we can write in the form of 1 plus lambda into x square plus y square, and we have 3 plus 2 lambda into x, 7 plus 2 lambda into y, okay, plus 2p minus 5 minus lambda p square equals to 0. Okay. Now, 1 comma 1 should satisfy this equation. That means 1 comma 1 lies on it, substituting x as 1 and y as 1 in this equation and seeing if there is a possibility of getting a lambda. For what values of p can we get a value of lambda satisfying this equation? That is what we want here. So, what is it we should look for? Okay. 1 plus lambda into 2 plus 3 plus 2 lambda into 1 plus 7 plus 2 lambda into 1 plus 2p minus 5 minus lambda p square equal to 0. So, that becomes our equation. When I substitute the point 1 comma 1, assuming that there is such a circle passing through the point 1 comma 1 and also the points PQ, capital P and capital Q, let us see what we can say here. Now, let us look at, let us find the value of lambda. For what values of P lambda is valid, lambda can be found. So, let us first club the values, let us club the lambda terms. So, we have 2 and then 2 lambda plus 2 lambda, that is 4 lambda, and another 2 lambda here. So, lambda into 6 minus p square, lambda into 6 minus p square here, and that is equal to the rest of the terms. Let us take it to the other side. What do we have? 2 plus 3 5, 5 plus 7 12, and this term there. So, minus 2p, we have 12 minus 5 7. So, taking the other side, so it becomes minus of 2p plus 7 here. So, what is lambda? Minus of 2p plus 7 by 6 minus p square. Now, we are to examine for what values of p we can find a lambda. So, clearly your p cannot be plus root 6 or minus root 6 because this becomes invalid. Now the question is, can p be in such a way that lambda is 0? If lambda is 0, what will happen? We will get one of the circles. S1 equal to 0 will be the circle. But anyway, is it always possible to get such a circle? Yes, such a value of p, that is possible there. So, what do we have here? So, p should not be plus root 6 plus or minus root 6. So, a possible value of lambda we can get only when p is not equal to plus root 6 and p is not equal to minus root 6. So, except for two values of p, we will always be able to find a lambda, and once we are able to find a lambda, we are able to write a circle S plus lambda S dash equal to 0, passing through the 2 points capital P and capital Q, and also passing through the point 1 comma 1. So, it would be possible to find such a circle which is passing through P and Q and also the point 1 comma 1 for all values of p except for two values of p, that is plus root 6 and minus root 6, and hence the right option is 3, option 3. Let's move to the next question. Question number 43. Three distinct points A, B and C are given in the two-dimensional coordinate plane such that the ratio of the distance of any of one of them from the point 1, 0 to the distance from the point minus 1, 0 is equal to 1 by 3. Then the circumcenter of the triangle ABC is at the point origin. Second option 5 by 4, 0. Third option 5 by 2, 0. And fourth option 5 by 3, 0. Now it says that a point P, suppose look at the point P, which in such a way that its distance from 1, 0, minus 1, 0 and 1, 0, they are in a particular ratio. Let's call this as A, and this is B. PA is to PB. PA is to PB. I think we'll not call this as A and B. We'll call this as Q and R. PQ is to PR is 1:3. That's given. Now the locus of such a point, first let's write the locus of such a point. Now capital A, capital B, capital C are all the 3 points which satisfy this kind of a condition there. So first let's write the locus of a point which satisfies this condition. What is that? X plus 1 the whole square plus y square under root into 3 is equal to PR. What is the distance between? This is x minus 1 whole square. PQ should be equal, 3PQ should be equal to PR. So we're using that. PQ distance is x minus 1 whole square plus y square under root. PR is x plus 1 whole square plus y square under root. Now squaring both sides, what do we have here? 9 into x minus 1 whole square plus y square plus is equal to x square plus 2x plus 1 plus y square. What do we have? The left hand side, 9x square, x square, 8x square, 9 into 2x, 18x, minus 18x and minus 2x here, so minus 20x. And what do we have here? Y square term. I'm sorry, that y square would get cancelled here. Oh, so this is a 9y square then. So that makes it 8y square. 8y square. And we have here, okay, minus 20x, 8y square, 9 minus 1, that is 8, plus 8 equal to 0. Right. So we will divide throughout by 8 here. So what does give us? X square minus 20a by 8, that makes it 5 by 2 x plus y square plus 1 is equal to 0. Now what are we given? We are given that the points capital A, capital B, capital C which are in the coordinate plane are all satisfying this condition. So instead of P we could have had A, instead of P we could have had B, we could have had a C also instead of P. So what does it mean? Now this, on this circle these 3 points will lie. This is a circle clearly. So ABC will lie on the circle. What is that circle? With the center as 5 by 4 comma 0. A, B, C are going to be points on that circle. So locus of, what we have done was we found the locus of a point P such that PA by PQ by PR is a constant, that is 1 by 3. And then we said what we are given in the problem is that A, B, C satisfy this condition. All these 3 points. So but what is the locus we have found? We found that locus to be the circle. So that actually has to become the circumcircle of the triangle ABC. So circumcircle of the triangle ABC is therefore 5 by 4 comma 0, which is the center of the locus of this point P, such that PA PQ by PR is a constant. That's 1 by 3. So answer is right option is, what is the right option? Option is 2. Option 2 is the right option. Let's move on to the next question. Question number 44. The circle x square plus y square equal to 4x plus 8y plus 5 intersects the line 3x minus 4y equal to m at 2 distinct points if first option m lies between minus 35 and 15. Second option m lies between minus 35 and 65. Third option m lies between 35 and 85. Fourth option m lies between minus 85 and minus 35. Now we have a circle x square plus y square minus 4x minus 8y plus minus 5 equal to 0. So clearly the center of the circle is half the coefficient of x and half the coefficient of y. What is that? 2 comma 4 is the center. And what is the radius? 2 square plus 4 square minus 5 under root. Minus of minus 5. That makes it 5. So that is 4 plus 16. 20 plus 5. 25 under root 5. 5 is the radius. Okay. Now, if a line has to cut in 2 distinct points, what should happen? The perpendicular distance from center to that line must be less than the radius. Clearly that must be less than the radius. This is the radius. So if the line intersects a circle in 2 distinct points, the perpendicular distance from the center to the line must be equal to, it must be less than the radius. When does equality to the radius happen? When the line becomes the tangent to the circle. So here D must be less than 5. What is D? The perpendicular distance from 2 comma 4 the center to the line. What does it say? 3x minus 4y equal to m, or minus m equal to 0. What is D given by? D, the perpendicular distance, is given by 3 into 2 minus 4 into 4 minus m by under root over 3 square plus 4 square. Perpendicular distance from a point to a line, ax1 plus by1 plus c by under root over a square plus b square, where x1 comma y1 is a point and ax plus by plus c equal to 0 is the line. So using that, what do we have here? So we have, this should be less than 5. Okay, so what is that? 6 minus 16, that is minus 10, minus of 10 plus m, okay, and a modulus by 5, that should be less than 5. So 10 plus m and a modulus should be less than 25. So 10 plus m should lie between minus 25 and plus 25. When is mod x less than a? X should lie between minus a and a. So 10 plus m should lie between minus 25 and 25. Therefore, m should lie between minus 35 and transpose plus 30. M's 15. M should lie between minus 35 and 15. Therefore, the option 1 is right. Option 1 is right. Next, move to the next question. Question number 45. The length of the diameter of the circle which touches the x-axis at the point 1 comma 0 and which also passes through the point 2 comma 3 is, first option 10 by 3, second option 3 by 5, fourth option, third option 6 by 5, fourth option 5 by 3. So let's have a look at this. Here we have a circle which is touching the x-axis at 1 comma 0 and it's also passing through the point 2 comma 3. We are interested in finding out the diameter of the circle. Now, clearly the center of the circle will lie on this line. This is radial line perpendicular to the tangent. So what is that? That's the line. This is the x-axis. What is the line perpendicular to it and passing through the point 1 comma 0? that is x equal to 1. So the center is having the coordinates as 1, and can we assume this length is the radius, isn't it? So I can write the coordinates of this point as 1 comma r. Okay, now this is also r radius. So what do we have? Now use the distance formula from the center to 2 comma 3, the distance is r units. So 1 minus 2 the whole square plus r minus 3 the whole square must be equal to r square. So we have here 1 plus r square minus 6r plus 9 is equal to r square. Okay, so now what we have is, so 6r is equal to r square cancels, and 6r is equal to 10. So r is equal to 5 by 3. Okay, r is 5 by 3, and we are interested in actually the length of the diameter. Therefore 2r is equal to 10 by 3. Length of the diameter is 2r equal to 10 by 3. The right option is, answer is option 1. Option 1 is the right answer.